What I would like to do in this video is to show to you graphically what you're doing when you're doing an independent t-test or a two-sample t-test. In Project 5A, we had two groups. We had an early group and a late group. The early group, we had 139 subjects. For the late group, we had 61 subjects. For Group 1, we had a means of 112.3 and then a means of 114.7 for Group 2. And we had, for Group 1, a standard deviation of 10.1 and a standard deviation of 10.7 for Group 2. Here on the graph on the right, you can see then the two means. Okay, so for Group 1, for the early group, we had 112.3, approximately in that point. And then for the late group, we had 114.7. With each of these means, we're going to have an associated confidence interval. And you can see here the confidence intervals in the chart. So this confidence interval for Group 1 is going to extend from approximately 110.61 to 113.99. And for Group 2, it goes from 111.96 to 117.44. Okay, so these are the confidence intervals for the data that we got. Now, what are we doing when we perform a t-test or a two-sample t-test or an independent t-test? What we're doing then is we are comparing two things here. Okay, we're taking into account the distance between these 2 points, and as you can see here, if we make the measure for the early group a 0, and then the distance between the early group and the late group is going to be approximately 2.4. This is what we have here on the left as the effect size. So we have a 2.4 difference. But we must also take into account the confidence intervals for these two groups. Now here you have the confidence interval for the first group, here you have the confidence interval for the second group, and here you have then the confidence interval for the difference between the two groups. Okay, so here we have the confidence interval for the difference between the two groups. As you can see, that difference is a little longer than the confidence interval that we had for the second group. It's a little longer than the confidence interval that we had for the second group. The null hypothesis for this test was that the mean of the early group is equivalent or the same, statistically speaking, to the mean of the late group. Now, when we look at here the p-value, we see that we got a p-value of 1.3, which is higher than 0.05. So if p is high, the null can fly. So in this case, this means that the two means are actually equivalent. They are similar, statistically speaking. Now, we're also trying to do modern statistics, and we're trying to get rid of p-values. So how can we do this without a p-value? Well, there are two things to notice here. The first thing that we need to notice is that when we have the overlap here, we try to map the overlap of the confidence intervals, we see that there is considerable overlap of the two confidence intervals. Okay, so we have a very high level of overlap when we compare the two intervals, confidence intervals. So this might be an indication that actually these two means are close enough to be considered equivalent or similar. The other test that I suggested in the video before was to look at the confidence interval that we get here for the test. And in this case, we get a confidence interval of minus 0.715 and 5.5152. Now in this case, we do go through 0, and remember what we said before. Yes, 0, that means yes, H0, or yes, H null. So in other words, we accept the H null. And we can see that here. You can see that the confidence interval for the difference actually goes through 0. So if we go through 0, then that means then that the two means are going to be equivalent in that sense. So notice that we have two graphic indications here to suggest that in this case we are accepting the null hypothesis. Okay, one is that we can see that there is a high level of overlap between the two confidence intervals, and the second one is that when we look at the confidence interval of the two means, it does go through zero. Okay, so if we can read off those two facts from the graph, we can get rid of the p-values, but we still use the p-value just to make double sure of what we're doing in this case. There's one more concept that we need to understand with this graph, and regarding the difference between the two means. In this case, we saw that the difference between the two means was 2.4. Now, that difference is measured in the same units that we have the confidence intervals in these two cases. However, we might want to express this difference in terms of standard deviations. To do that, we do that with what we call Cohen's d. And Cohen's d is going to be calculated based on the effect size here, so in this case 2.4, divided by the standard deviation of the whole data. And in this case it would be what we call the pooled standard deviation, and in this case it would be 10.286. Now, as you can see here, we get that the Cohen's d value is 2.33, and the unbiased d, so this is taking into account the degrees of freedom, is 2.32, and that is going to be then Cohen's d. What does that mean? Well, here we have a little picture so you can see that. So basically here is measuring that distance between the two means in terms of standard deviations. Now, anything that is under 0.2 is considered small. So here actually we do have a big effect size when we compare the two. This becomes more relevant when we actually have a difference between the two. So we will see that in the next example. So now let's take project 5b. So in this case we had two groups again, the early and the late group, but now we had different means. So we had 49.2 and 54.7 here. As before, each of these groups is going to be associated with a confidence interval that we have there, and what we want to do then is we want to compare the two things. We want to compare the means. So here, if we compare the means, we can see here that the difference is actually 5.5, the difference between the two means. And when we add the confidence intervals for the two groups, you can see here, let me add the confidence intervals. Okay, there are the confidence intervals for the two groups. We can see here that there is very little overlap. When we compare this with what we had before, we had a lot of overlap. Here we have very little overlap. Now in this case, we can also see that the p-value is 0.009. 0.009. P is low, H null must go. So in this case, it means that the two means here are not equivalent. Notice in this case, when we look at the confidence interval for the difference that we have here, it goes from 1.367 to 9.6326. Okay, here we see that it doesn't go through zero. Okay, it doesn't go through zero. Before it went through zero, and we saw before that there was a lot of overlap. Here we have little overlap and it doesn't go through zero. And in this case then we reject the null hypothesis. when we calculate the d value, the Cohen's d value, in this case we get a Cohen's d value of 0.402. So in this case, when we look at the pictures here, we have a d value of 402. We see that these two, in terms of standard deviations, these are very far away. Therefore, we conclude that they're not equivalent. Okay, so this is also what Cohen's d is going to help us determine. So we have here a big effect difference. Anything higher than 0.8 is considered a big size effect. So here the difference is big. It's a Cohen's d value of 4.02. So to accept or reject the null hypothesis, we can do it three ways. We can do it via the p-value. So remember, in this case, if, like in this example, p is low, then the null must go. So we reject the null hypothesis. Now, why do we reject the null hypothesis? Well, here notice that when we look at the difference and the confidence interval of the difference between the two groups, it doesn't go through 0. Okay, so no 0, no H0. So in other words, we reject the null hypothesis. Also, when we look at here the amount of overlap between the two groups, we see that there is very little overlap. So if there's little overlap, then that also means that we are going to reject the null hypothesis. When we compare that with the first group, so here we see that we have a great amount of overlap, okay, and we see also that we also go through 0. Okay, so here we have a lot of overlap and we go through 0. Now in this case, notice that the p-value was 0.13. P is high, then the null can fly. So in this case, we conclude that the two means are actually equivalent. Okay, so if we have overlap, a great amount of overlap, and we go through 0, then we do not reject the null hypothesis. Okay, yes 0, yes H0. So we accept the null hypothesis. Lot of overlap, and we go through 0, we accept the null hypothesis. Then in the other case, when we have little overlap and we do not go through 0, no H0, then we reject the null hypothesis. Notice that we can then decide whether the null hypothesis holds or doesn't hold just by looking at these charts and disregarding the p-value. Now, we are still reporting p-value because in the field p-values are still being used, but notice that more and more we're going away from p-values and we are trying then to determine all our values and our tests simply by looking at the graphs.